Hello, and welcome back to VFX with Natron. Alright, so last time I had asked at the end of the video if people had any questions. Well, of course, I waited around for all of, 5-10 seconds and nothing popped up. So I was like, oh, everybody knows what they want to know, and we're all done. But lo and behold, I was wrong. You know what happened? Somebody posted some questions. And so I thought I would cover at least one of the most important questions. And then the rest of the video might be around another one. So let's see. Question number 1 was, do you have a peg leg? That's a bit personal. Nope, I've still got both me legs. So, sorry, if that changes your opinion about viewing this video, well, I'm sorry about that. Can't do much about it. Well, I suppose I could do something about it, but I'm not going to. I like my legs the way they are. But I do have friends that don't have both legs. One does have a peg leg. His name's Pirate J. And he has a YouTube channel. And I'll mention that in comments afterwards. But for those who missed it, you can check out his channel. Because again, he's on YouTube. His name's Pirate J. Anyhow, back to the next thing. Let's see. Somebody wanted to know more about other types of expressions other than frame. Using frame. Ways of talking about things or doing things. So I thought we would talk about linking today. And without going too much further, I'll say let's start. Wrong video, book. There we go. Alright, yes, and I've added control keys, or added a little thing that will display the keys I press over here in the left-hand corner of the screen. So, the first thing we need to do is talk about, types of, things we can do, types of there's a thing in Natron called linking, okay? To demonstrate this, let's first create a text node. So I'm going to make a text node, and a lot of people are going to enjoy this one because this is going to be something that I have a feeling a lot of people want to do with text nodes that you can't really do by default without using an expression. And we're going to write probably the most complex expression. Well, I won't say it's the most complex, but there's other things that are more complex. But this is the most complex that we'll be able to do in probably this amount of time. So I'm gonna make a second text node as well, and we're gonna put over here on the second tab of our text nodes. You have a thing called a label, and this is where you're supposed to put a label for something to identify it. You're not supposed to rename your nodes, though you can. You can give nodes custom names if you want. Natron isn't going to stop you. Anyway, we're going to call this one source. Okay? And the reason that we're called... Whoops. Oh, I want to click here. And you'll notice down here, it says source underneath text 2. And what we're going to be doing is we're going to type in something like Natron. You know what we'll do? We'll type in Natron, and then we'll hit return and type in nation. Okay, so we have 2 lines of text. Whoops. Helps if I write this in the actual text window as opposed to in the label. Let's type that as source. That's fine. It can be caps. Over in our text field, we're going to put in. I'm going to paste. Oh, foo. I'm just starting out this really well. Natron Nation. I have butterfingers with my fingers. The big, huge, like swords that miss their target. I didn't say I had good aim. All right. Anyway, so we have in our source node we have this text. We look over here. It says Natron. We don't care about its formatting because we're not only going to use text2, the source node, for a reference point. Now, I'm going to hide everything of text2 node and except for our text field because that's all we need. And over here on text1, I'm just going to, for the moment, eliminate the text so that, and I'm also going to set it to, for now, I'm going to set it to center interact, and we'll also make it nice and big, probably around, I'll say 150. All right. Now, then I'm going to hide everything but it, and I'm also going to increase our properties panel so that it can show two nodes simultaneously, or two sets of properties simultaneously. That way we can look at both nodes simultaneously. So set that to 2, double click on source the source text node, and we see our source text is Natron up here, and what we're going to do is I'm going to hold down the control key, and for some reason it's not displaying on the display that I'm holding down the control key, but if I hold down the control key, left click and drag from my source node, you'll see that it says linking hard link from text2.text, and I'm dragging it to my text1. And when I let go on text1, you'll notice this green line appeared between the two. That indicates that I have linked the two nodes together. Now the text in text1, what we see up here, is completely based off of text2. So I'm going to go up here. If I change this to something else like hello, and then I hit enter, and it updates down here. Now, there's nothing I can do to text1 to change it because it's hard linked. It is completely dependent on text2, or I should say the text field of text2. So the only thing I can do, I can change its size, as you can see, but the actual content of the text node or the text field is completely derived from the source node. Okay, so I'm going to unhide text1 for a second, and I'm going to play with some more formatting, I think. I'm going to turn off auto transform because I want it to be up in the upper left for the moment because of something we're going to do in a little bit. I'm going to switch my text back to Natron Nation. Oops, and I'm going to hit a return as opposed to a space there. All right, so we have this. So actually, I'm going to put on the transform again. You'll notice right now that our text is centered, but it is not justified. Or I should say it's left justified relative to one another. That's annoying. You see down here that it says, oh, we can set it so that it's centered, and it didn't do anything, or at least that's what it looks like at first. To fix this, what we're going to do is we're going to turn off transformation, because that actually makes it so that the justification can take place. So what we have to do to make the justification take place is we have to take the wrapping, set it to one of these options here, like word, and then we tell it that we want it to be horizontally center aligned and then vertically aligned center, and now it's back in the center, and you'll notice that it's purely center justified. In fact, I can switch it from left alignment to right alignment to center alignment. So in case you didn't know that, that's how you go about doing that. All right, but we're going to hide this. The reason I wanted it is so that this is nice like that for later on in our example. Now, So we can't do anything here. All we can do is if we right click on it, we have the option, we can copy it. Okay, that's not very useful. Or we can unlink it. So what I'm going to do is unlink it. The other type of thing, there's another type of hard link we can create, which is a clone. We already experienced this once. A clone is, instead of being a hard link of one field of a node, a hard link, or I mean a clone, is a hard link of the entire node, every single bit in the node. But the cool part about the clone is after you cloned it, you can unlink pieces of it so that you can access it. And sometimes it's a lot quicker, especially with something as complex as the text node, to make a hard linked copy of the entire node and then unlink the attributes you wish to be different. Like, for example, you could keep all your formatting handled across a whole bunch of different nodes and then just change the individual text and individual fields for doing whatever you want to do to it. So to clone it, I'm going to use the text2 as our example because I'm saving text1 for if we get to something a little later. All right. So to clone source 2, what I would do is I can right click, go up here to the edit menu, over to clone nodes, and you can see that it says Alt K, and that creates a clone. All right. And a clone has this pink line. Before we had a green line, now we have a pink line. And if we double click on this, we can see that every single one of our attributes, every single point is blacked out. We can't modify any of these on this clone. It is 100%. All right, I can reset its center point if something changes the offset. This isn't hard linked, but every variable that we could change in source 2 can't be changed in the clone of source 2 unless we unlink it. And we unlink it by right clicking on it, and then we say unlink from source 2, and lo and behold, now I could change that. And so I can sit here and I could just say put in hello again, hello, and we can see text 2, we have Natron Nation. Text 2 clone, we have hello. But if I go back to text 2 and I unhide its bits and I would just say change its font size, you can see that by changing the font size for text 2 to 278, which pushed it off the screen, it did the same thing for the clone, except for now it's pushed the hello off the thing. That can be useful. There's a lot of times that clones are very, very, very useful things. And I might get into a really tricky thing that could be fun. That's another episode sometime. Oh yes. Before I get too much further, I want to remind people, if you have a question, start asking the questions inside of the Facebook chat. And we'll get to it in, or I will try to answer them at the end of this episode, so long as it doesn't, so long as we don't run too long. All right, so we've talked about a hard link, and by the way, you'll notice that text 1, when I broke the link, it kept the text that it had gotten from the hard link, so it retained the Natron Nation. So let's talk about expression linking, okay? Or which is actually soft linking. And by soft linking, what it means is it's a link that's made, but it can be changed via programmatically. And there is another way of doing this. This really comes important if you get into making your own custom nodes and groups, but we're not going to be doing that today. What we're just going to do right now is I'm going to show you how you can do it with a simple a node like this. So we're going to edit the text field here as an expression. We're going to set an expression for it. And we're going to take text 2. Whoops. Wait a minute. I did the wrong thing. Let me copy the text from here, put it back there, shrink text 2 down, go back to text 1, delete the text, set the expression here. All right. So text 1 is empty. Text 2 has our text that we want to copy. If I control click inside of text 2 and drag it over into my expression and let go, I've created a soft link. And what's the difference? Well, there's a big difference. Let's first hit OK and make sure that that actually worked. As we can see, we still have the green line, which indicates it's linked. We have a linked field. We can see that we have an expression up here that's connecting it, but this expression is linked. The link is to text 2. And if we look at that expression, we can see that it said what the expression is in text 1 is it says it's declaring the node, which is the name of the node, which is text 2, dot, which means that we're going for a sub-attribute, text, which is the element of or the property that we're going to try and access. We're going to access the text 2's text, and we're going to get it. Okay. Now that we've got it, what can we do here? Well, the easiest thing I can think of to do it is we're going to pick a specific letter out of this. Okay. One of the things that's nice about Python is if you put in a letter number or inside of some brackets, letters are treated as arrays and or in a lot of ways. Anybody who knows enough about Python knows that. So I've told it that I want to get from the array of text letters, I want to get character number 0, which is the first character in our list. When I hit OK, look at that, we have N, which is the very first character in this. It's N for Natron, which we have a lot of N, so how do we know it's the first one? Well, let's see. Let's find the R, which is letter 4, which will be letter 3 here. So we hit 3, and there we go. We have an R. Okay, well, let's turn off our overloads so that we can see it. All right. So let's go back to here. Now, I wanted to point out this, that there are problems with using this. If I set this back to 0, in Python, you can set a range. You can say, I want to go from 0 to, with a colon, that means in this particular situation, that means to character, let's say 5, okay? And you can see down here, it says result, and it says Natron. Okay, we hit OK, and you'll notice that we get this little dialogue that says the expression is invalid. It's a half-truth. What it's doing, it actually has evaluated it, but it's only evaluated it for the first frame. If we move forward in time, what it's doing is it's only updated it for that particular cached frame. Now, how you say, well, that doesn't look like it did it. How do you know that it's done what you're saying? All right, well, let's prove it. I'm going to edit the expression, and I'm going to change that 5. What we're going to do right now is we're going to try and make it so that as the frames increment, it changes, it adds text to our phrase on the screen. So we're going to change this from 0 to frame. Makes sense. We used frame in the except for I got to turn off caps lock. Frame, because it is case sensitive, and you'll see it gives us a result down here that looks positive. We hit OK. It says the expression is invalid. We get our first frame, which is cached. All right, but when we hit play, it just sits there and does nothing. And this is going to bring up the next point, which is, and you'll also know, because it's a broken expression, this also causes Natron to pause a lot of times because it's doing a lot of stuff in the background, and it may take a second. Also, our green expression text has disappeared, which you might go, well, there's no expression there. There is an expression here. It's just, it's a half-functioning expression. Be careful with this particular thing. All right. So let's step back for a second. I want to talk about before we move into what's called the multi-line expression, I want to point out something that Natron is taking a shortcut. Whenever Natron is dealing with a single line expression, it automatically assumes that it's using this thing, getting a return value. It has whatever you're doing is returning something. It must return something. But when you're doing multi-line expressions, they're more programmatic. They're more like real programs. And so you have to actually specify the return value. Okay? So right now, this is... I'm hitting a lot of back arrows, as you can see. Right now, this is basically what this is doing is the equivalent of me typing RET equals text2. Okay. This is the exact same thing as if I didn't have this bit here. But when we move to a multi-line, because we could have a return value from any potential line in our code, it is imperative that we know that we have to define that, or we have to tell it specifically that we want to return something at the end of this at some point. Okay. All right. So with that, we're going to go to multi-line. And we saw that it was broken when we did the other thing. So how do we fix it? Well, first I'm going to hit return, and, oh yes, you can also tell that, if you're not multi-line, you'll see in the result down here, it will say error unexpected new line character /n in quotes. That just means if you see this, it means you don't have the multi-line button pressed. Okay. So, up here, we're going to put back in our colon frame. Okay. What we're going to do is put in text. Okay. Now, I'm going to let you know, I technically could have put, no, I'm not going to get into that. Oh, by putting text here, there's certain types of math that don't work if you directly try to output it with the return. In other words, if I put RET there, sometimes things will work, sometimes they won't. I don't remember if this is one of the ones that does work. But it's always better to just do it this way. All right. So what we've done is we've assigned this information to a variable named txt. And what we're going to do here is we're going to type in ret equals text. Oops. Txt for text. Okay. Now, magically, what? Wait a minute. That doesn't make sense. That should have worked. Uh-oh. Natron's turning me into... Oh, I know what it is. Of course. Pardon me. We can't do the actual... we can't do the operation, the text operation on the actual text node. We have to do it on the text itself. We can do it here. That was the key. So we have to get the information from the other node, store it locally in a local variable to this node, which is our text, and then we can perform this operation on this. Otherwise, Natron has to go through cycles where it talks to the other node to try and get that information, and it can happen as fast and it breaks things. So right now, what we're doing is we've stored the text locally in a variable. And now we're turning it, and now if we do this, lo and behold, everything works. And if we go hit play, lo and behold, it went really quick. And that was way too quick and probably not very useful for anything that we would want to do in a real situation. So we're going to actually try now to turn this into something a wee bit more complex. And I had a step between, but I'm looking at the time and I know that I'm going to skip over. I was going to go over a little bit about try to keep your code clean. All right. I highly recommend when dealing with variables, if you're dealing with outputting something, when you deal with, we're going to deal with something called a condition. Okay, and you can, in theory, make it so that you can put multiple returns inside of various points of your code, but can lead to what's called spaghetti code, where you can't tell where the code is broken because it's breaking at some point, and then you have to say, oh, was it this return up here, was it that return down there, or was it this one over here? You don't know. All right, so what I recommend doing is setting up a variable. And in my situation, what I'm going to do is I'm just going to look. I want to make sure that I have my variables set correctly. All right, so my variable that I'm going to output to it's going to just be called out. Okay, for right now I'm going to set it so that out is just an empty text variable. Okay, that's what the quotes do. It's just a text. It just says that is a text variable. Okay, now one of the other things we want to do to make this useful is we want to actually, before this, I just like doing this in a little order. I want to get a count of all the characters in our text, the text that we just copied. I want to get it because I want to pause on each letter, so I want to be able to go through it. So I need to get a length, because the text too right now, that could be anything. We could write anything in there and it would change it dynamically. So I can't put something hard. I actually have to get the actual full however many characters are in that. So I'm going to put in a variable I call CNT for count equals LEN, which stands for get the length of something, or the length in this case. What we're going to be getting the length of is how many characters are in our text. Okay, so that just gave us that, and for right now I'm going to type in ret equals out. Okay, and right now you can see that result now is nothing. So for right now, what I'm going to do is I'm going to type in this other variable thing here called str, which stands for I'm going to be turning count. Currently is a number. It got the count. The length is a number. It's however many characters are in it. I'm going to convert that number into a piece of text by doing what's called casting, which is what str does. Okay, so I'm going to str CNT, which is going to turn it into a piece of text, and then we're going to set it to the output, and now I can see that we have exactly 13 characters in this. Okay, so that's why if I change that, it would change, and I want it to be able to change, okay, because that's important. But for right now, I'm also going to we're going to keep this down here so that we can see what we're doing for the out, so we can sort of put things in later on. I'm going to declare, however, keep my out up here. Out equals quote quote. And now let's see, what's the next thing I want to do? I want to add some way of offsetting in time. I don't want right now when we ran this animation, it started off at frame 1 and it just spit out the text as quick as it could. I don't want to do that. I want to be able to set some frame that it starts at. So I want to make a start frame, and I'm going to set it for right now to frame 24. Okay, that's just an arbitrary. You can change that to whatever, but right now we need it for the purposes of dealing with math. Then I want it to hold on a given frame when it gets this specific character for so many frames. So I'm going to make a hold number. This is going to be so it doesn't go blah, 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 and print out everything so fast that nobody can read it as it progresses. So hold is going to be how many frames we're going to hold it for. And I'm going to set it for right now, because we don't want it to be too long. We want it to progress quickly. 5 frames, which is about 1/5 of a second approximately. Okay. Those are our variables that we need to do something interesting. We can offset it, we can retime it, we can change by changing hold. I can make it take less time. If I set it to 1, it will zip out. If I want to take it longer, I can make it longer. I can also change this so that this would work with as actual words. Like there's ways of making it work with words. But that's something we can talk about another time if we have time. I want to get this done. So Now what we have to do is set up a condition. And a condition is the most obvious one is the if-then statement. So we're going to type in if, let's see, I believe it is our frame is, I believe it was, let me just verify, greater than and equal to start. And by the way, I wrote this ahead of time because I'll tell you right now, it takes me a little while to write out my program, so I'm cheating a wee bit by looking at this, but I'm going to dictate it as I go. So if our frame is greater than or equal to start, okay, it's going to do something. That means when it gets to the start, past the start, or to our start frame, which is 24, it's going to do something. But we also want to make it so that when it's done doing that thing, it will do something else, because the problem is once we get, now it technically there's a cheat we could do, and it wouldn't matter, we could put another if statement after this, but really in all honesty, in good programming, you'd never ever want to use two ifs for the same type of evaluation. So we're going to do this the right way. I prefer to do things the right way. So we're going to say and, okay, frame is less than equal to let's see, we want it to be the count, okay, times hold, because the hold, we're going to multiply the however many letters by how long we're holding each letter, because that's going to, those two things can change. Okay, we can change how many letters we have, and each one, if right now we want to multiply it by 5, I have, you know, I had, what did we say it was, oh, I forgot how many letters it was. I think it was like 19. Let's say 20 times 5. Okay, that would be 100. Okay, so we'd have, that would be 100 frames, but if we added another letter, that makes it 105 frames. So we don't want to hold it. Yeah, anyway, I don't want to dwell on that. I think you guys get the point there. All right, the other thing we have to do is we have to say that where it's going to do it. We also had it where we have a point in time that we're going to do, so plus the start frame. Okay, so we're going to take the count, we're going to multiply it by however many, that number by the whole frames, and then we're going to add to it our start frame to figure out where in time it's offset by. Okay, and that is where it's going to end. Okay, so what we're about to write is going to start at the start frame and end at this, at control plus, or control at count times hold plus start, which is the end frame. Okay, now we're going to hit return, and we don't get auto indentation in Natron. If you write this in a code programming language, you can, or coding program, you can add to this. We've passed the half-hour mark. I'm going to keep going. I want to make sure I'm thorough about this. So we're going to type in. We've hit tab because we have to indent, because this is a condition, and this, oh yes, I put a colon here in case you missed that. The colon indicates that we're moving to a new line for the rest of our condition. Actually, it means that what comes after it is what it's going to do. That's the then. Then do this next thing. And this indication, because it's Python, says we have to indent. It doesn't matter how much, we just have to stay consistent. I'm using a tab in this case. So we're going to say out equals text, or txt, and then we're going to say 0. Whoops, apologize, I just hit my microphone. 0, 2. So we're going to take the first letter, 2, and this is where it's going to get complex. I'm going to first start off with, we're going to put some brackets, and we're going to say frame. Now, this is what works for me. So if somebody knows better text and comes up with a better way of doing this, please, we're going to take our current frame, and we're going to subtract the start frame from it. Okay? Why are we doing this? Because we need our actual text starts at number 0. Okay, so if we're at the start frame, we're currently 24 frames in, so we have to subtract 24 to get back to 0. Okay, so that gets us to our first character in our text. Then we want to add in our hold time. Okay, and this will make more sense. Plus hold. Okay. And we do that. We're doing this afterwards because I want to ensure. I'm trying to guarantee it. I'm trying to force things, and I'm going to put these in parentheses. Okay. And then let's see. We want to. After that, we want to take the result of that, and we're going to modulo, which we discussed each time or discussed before. We're going to divide. Oh, wait a minute. I'm sorry, I'm not going to do that. I'm going to divide this by the hold time, not the modulo. I'm going to divide this by the hold time. Okay, so we're taking that and we're returning a value. We're dividing the whole thing, the result of that, and coming up with a value. And what that's going to do is it's going to return a single digit, hopefully, or a single set of digits that's going to be below our modulo value. So as long as it's below the modulo value, it will always return the same number. In other words, this will make sense, hopefully, when it's all done. I don't like talking about programming all that much. I want to make sure my parentheses are correct. Okay, we're going to take the result of that, and then we're going to divide take that, and we're going to want to make sure we've got it right. Okay, we're moduloing it by the count. Okay, this is how many letters we have. Okay, this is the entire length of our whole thing. But we must add +1. Right. Okay, that will make sense. This makes more sense to me. So, all right, what this is doing is the count +1. We're doing this because we're starting. This is going to return. We don't want to start. We don't want our last result to be 0. We want our first result to be 0. So what we're doing is shifting it a smidge. I believe it was. Oh, math is escaping me at the moment, and I apologize. As I say, programming not my most strongest thing. But all right. So now we've our count was 13. What we're gonna do is just we're gonna comment this out, or we'll get rid of this for the moment. And right. So this should, if everything worked correctly, this little thing that we've written here is going to get each character of our text. Once we get to frame 24, it's going to get each character of our piece of text, and it's going to return it one at a time. Well, it's going to add that character, so it's going to go from 0. It's going to count up to whatever character we have until we get to the end. Then this is going to this section is going to end. Once it ends, we just want to return the whole thing. So we need to type in L for else. Technically, it's a shorthand for else. Okay, but we're actually going to say if, because we want to make sure this is another condition. And the if is going to be if the frame is greater than, I believe it is. Let me just make sure something. Oh, up here I made a boo-boo. I want that to just be less than, not less than, equal to. The frame here, we're going to use this and copy that, and we're going to say elif frame is less than, this is where we want to do equal to, equal to, and then we're going to say this exact same, actually it's the exact same thing. We're going to say if it's less than or equal to this, or excuse me, not less than, if it's greater than or equal to. I'm just checking my code, making sure. All right. So why are we doing this? This one deals with it. This is dealing with our text right up until the point that our text ends. Okay. Once we've put our last piece of text in, we want to just show the text the entire time. So what we're going to do is this gets our range, the two ranges, the beginning and the end. After we pass the end, we wanted to just display the result. Well, that's easy. So here, this just tells it that we're evaluating for the result, and we're going to say that the out equals, and in this case, just text. There we go. And then here, it's going to return our out, and we hopefully have something that will work. And let's return it. We haven't gotten any errors. We're going to hit play, and lo and behold, there we go. And it says it, and it holds it for the rest of the time. And we've gone a bit past the end of it, and it starts over at the beginning when we get to it. So I know it's a little vague. That's the problem with the live streams. I would try to get into the more detail of why the programming and my logic behind some of this a little bit better if this were a live stream. But I hope I've given you guys enough information. So at this point, you know what? We're going to keep this playing, and I'm going to go over here, and I'm going to look through the questions over here, I think, and try to answer some of these, or see if there's anything that can get answered. First thing, Martin Levy says, or Levi says, "Hey, William, how are you doing?" "I'm doing dandy, thank you very much." Okay, he says, just to remind you, the one catch is variables. Yes, I went over that, actually. I explained that the variables must be, demonstrated the fact that we can't always access. We have to declare the variable at the beginning. That's what we did with the text, because it creates issues. All right, let's see, otherwise math... All right. Yes, that also applies to a lot of math. In fact, the range that we were doing is a type of math. It's a math routine. Okay. And that I showed how the link. I told him to remind me today, and I think I went everything. All right. LOL. Yes. Okay. So he asked if there's no integer function. Yes, there is an integer function. Here I shall show you. Right here, we'll go into here. Edit expression. If I wanted to take, let's see. If I will turn it out temporarily. Okay. So we're going to say out equals CNT. Okay, and it out is now technically it's an int. It's not actually doing it. So what we're going to do is str parenthesis CNT, and then we get 13. Okay, now if I want to turn CNT into, let's say I want to turn that back into a string back into an integer. Now you got to be careful with this, because I don't think you can turn, I don't know if text can actually be turned into an int. We can try. Let's try CNT. It's just, I didn't do that. Let's say we can just say so CNT equals OUT, which is, and then I'm going to type in int parenthesis, which casts it as an integer. Okay, so I'm taking the value that was out, I'm turning it into an integer, restoring it into CNT. Okay, and just to prove this worked, if I put out back equals CNT, you can see we don't have a result because it's an integer, so the result isn't doing it. So if we type in str parenthesis CNT, we get 13. So basically, we told we set the out to 13, the text of out to 13, because out is a text field. CNT is an int, so we told it to take that text field, convert it into an integer, store it into CNT. So it took that, even though it's the same thing. I mean, here, let's put 24 here, all right, just to, and you can see the result here is the exact same thing. If I've told it that I want 24 to be a string. Let's see if I could put in hello. It says it's an error because it's text. Text doesn't have. I'd have to turn text in. Text is a char, a character. So you'd have to do that. Okay. We've gone a wee bit over. I'm gonna call it here. I hope that enters anything. Time to wrap that up in a Pi node. We could wrap this up into a Pi node. I'm gonna tell you what I'm gonna do. I'm gonna take this whole thing here. I'm gonna copy it. I'm gonna paste it right into the comments for this at this point in time, and there you go. That way everybody can take it and copy it and save it and do whatever you want. If you want to turn it into a Pi node, go ahead. All right. I'll talk to you all later, and keep on natroning.